Welcome to Chemistry Online. Today we're going to talk about elements, mixtures, physical states, and how these are described by the kinetic molecular theory. Basically, matter is any substance that occupies space and has mass. The simplest form of matter is an element. It contains only one type of atom. And a compound is a combination of two or more elements in a specific and constant pattern. An example would be methane, that's natural gas, where we have one carbon and we have four hydrogens bonded to it. We can define any one particular type of matter as a pure substance. If we combine two or more of these, we get a mixture. Now, mixtures come in two forms, heterogeneous and homogeneous. In a heterogeneous mixture such as gravel, if you take a sample from anywhere within our little picture here, you get a different assortment of rocks. It is heterogeneous. A homogeneous mixture, on the other hand, when we take a sample, we always get exactly the same composition. An example of that is a solution, and again we can separate the components of a solution simply by physical means. If we start off with salt water, it evaporates, we're left with salt and water. Look at a couple of simple examples. Here we have a rock. Is a rock a pure substance? Well, it looks like it's solid rock, but if you look at it on the magnified scale here, a thin section shows that it is indeed an aggregate and is therefore a heterogeneous mixture. Gold bars. Well, these all look differently, but on an atomic level, it's nothing but gold atoms. It's an element, and it's a pure substance. Table salt. Little crystals of table salt all look different, but they only contain sodium and chlorine atoms. It's a compound, and therefore it's a pure substance. Look at some examples here. Air. When we take a sample of air within a local region, we'll always get the same basic composition. It's a mixture of gases, and therefore it is a homogeneous mixture. Ground pepper is a classic example of a heterogeneous mixture. Seawater, as we've seen, within the same sort of area, the salts are going to be dissolved in the same ratio, and it will be homogeneous. Sugar. Sugar is a chemical compound. This is sucrose. It contains carbon, hydrogen, and oxygen, always in the same composition, the same ratio, and actually the same spatial arrangement. Gasoline is a mixture of hydrocarbons, and gravel, as we've seen, is a classic example of lots of little rocks. Now let's go and look at physical properties. We're going to look at the states of matter, and we're going to see how the kinetic molecular theory describes the states of matter and transitions between these states. We're dealing here with solids, liquids, and gases. This little movie shows the particles in a solid, liquid, and gas as they're described by the kinetic molecular theory. Now, just in general, solids have defined shapes and they have defined volumes. Liquids, we'll see, have a defined volume, but they take on the shape of whatever container they occupy. And finally, gases have neither defined shape nor volume, and they take on the shape and volume of their container. We can have transitions between physical states, melting of a solid to give a liquid, and then freezing. These transitions occur at defined temperatures. The melting is called the melting point, and the other is the boiling point of a substance where we go from a liquid to a gas. Look at a simple example. This is bromine. Bromine was frozen in this vial. It's melting. We have solid bromine on the bottom, liquid, and bromine in the gas phase above it. has a melting point of minus 7.2 and a boiling point of 58.8 degrees centigrade. If I ask you what the physical state of bromine will be at minus 20, well, you look and you say minus 20 is below the melting point, therefore this is going to be solid bromine. At 80 degrees, while our boiling point is 58.8, this is above our boiling point, so we're dealing with bromine in the gas phase. And finally, if we were at 0.12, minus 0.12 degrees centigrade, that's below the boiling point, but it's above the melting point, so we have liquid bromine. Now these states can be defined by what we call the kinetic molecular theory. In the kinetic molecular theory, all particles are assumed to have intermolecular forces that attract them to each other. Imagine this little pile of magnets where magnetism is our intermolecular force, and they're stuck together in a lump. Now, if we have a solid, the kinetic molecular theory tells us that particles are always in motion, but in a solid, they don't have enough energy to overcome the intermolecular forces, so they just sit there. If we take a solid and we put in more energy, the particles now have enough energy where they can slip and slide over each other, but they still can't break the intermolecular forces between them. Finally, when we get to the gas phase, we have put in enough energy that we have totally overcome the intermolecular forces, and gas particles fly around until they hit each other or their container. This means, according to the kinetic molecular theory, the particles in a gas are highly separated, making them compressible. They have minimal attractive forces, therefore they take on the shape and the volume of their container. In a liquid, the molecules are closely spaced, not compressible. The attractive forces are intermediate, they can move around each other, but still they have a defined volume and take on the shape of their container. In a solid, we have strong attractive forces holding the atoms or molecules in relatively fixed positions. It's not compressible, and it has a defined shape that's independent of the container.